So this question gives us two matrices and we are supposed to do some arithmetic with it. And we find A plus B, A minus B, A times B, B times A inverse, and B inverse. So we're going to try to do that a little bit at a time. So we're going to go ahead and add matrix A and matrix B. So what is A plus B? Well, A plus B works the way you'd want it to work. You just add the numbers in their respective locations. So 1 plus -4 is -3. 3 plus 1 is 4. -5 plus 3 is -2. And 2 plus -6 is -4. So as you can see, that's a favorite strategy because it is done exactly the way you'd want it to be. But they're not all done that way. The next example is 3a minus 4b. But again, pretty much the way you'd want that to be done. So 3 times a, so what will that be? 3 times a, 3 times this matrix, 1, 3, -5, 2. I don't like to use minus. I like to change minus to plus and negative, just for clarification purposes. Plus -4 times b. What is b? -4, 1, 3, -6. And then what do I get when I do that? Well, this is called scalar multiplication, which works the way you want it to. 3 times everything in its position. So 3 times 1 is 3. 3 times 3 is 9. 3 times -5 is -15. 3 times 2 is 6. Plus -4 times 4 is +16. -4 times 1 is -4. -4 times 3 is -12. -4 times -6 is +24. And then what are we going to do? Then we're going to go ahead and add in the respective locations. 3 plus 16 is 19. 9 plus -4 is 5. -15 and -12 is -27. 6 and 24 is 30. So we've done both of those. We said that A plus B was, let's see if I can show everything here. There's A, there's B. We said A plus B was -3, 4, -2, -4, and 3A minus 4B was this. So before we go on, let's check those. I will put those matrices in for A and B in the graphing calculator, and then we'll check to see if we've done them correctly. So clear all that. Matrix, I need to put in matrix A, which is not that. Matrix edit. Matrix A is 2 by 2. And it is 1, 3, -5, 2. 1, 3, -5, 2. Second quit. And then matrix B is what I'll put in next. Second matrix edit. Matrix B is 2 by 2. 2 rows, 2 columns. And I get -4. 1, 3, and -6. Whoops, didn't hit enter apparently. -6. No, 3 is what I need. 3, -6. Boom. -4, 1, 3, -6 is B. I always like to check to make sure I've inputted them correctly. So matrix A, 1, 3, -5, 2, check, and matrix B. So we want to do A plus B, matrix A plus matrix B. And notice when we did this by hand, we said that it was -3, 4, -2, -4. What do we get here? -3, 4, -2, -4. We also want 3 times matrix A minus 4 times matrix B. Whoops. Four times matrix B. And again, when we did it by hand, we thought the answer was 19.5, -2730. Let's see what we get here. -19.5, -2730. Good. So where do we have to go next? Well, this is where it gets interesting. I want to do AB and I want to do BA. Okay. So we've got matrix A and matrix B here. And we want to do A times B. So what is that process? How does that work? Well, matrix A times matrix B. Write them down next to each other. 1, 3, -5, 2, times matrix B, -4, 1, 3, -6. So here's the strategy I like. Circle the rows of the first matrix. Circle the columns of the second matrix. There's 2 rows here, there's 2 columns here. My answer will be 2 rows, 2 columns. So AB will equal 2 rows, 2 columns. Row, 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 row. Now how is this going to work? Watch. 1 times -4 plus 3 times 3. First row, first column. 1 times -4 is -4. Move over, move down. 3 times 3 is 9. First row, second column, 1 times 1 is 1. 3 times -6 is -18. Second row, first column, -5 times -4, +20. 2 times 3 is 6. And then -5 times 1, second row, second column, -5 times 1 is -5. 2 times -6 is -12. So I believe, if I have done this correctly, I believe that matrix AB will be -4 plus 9, which is 5. -1 minus 18, excuse me, 1 minus 18, -17. 20 plus 6, 26. -5 minus 12, also -17. Interesting. So let's jump to the calculator and see if that's correct. We've already stored AB in the calculator. So matrix A times matrix B gives me 5, -17, 26, -17, which is what I wanted it to be. All right, the next thing I need to do is to find BA. So you might think that AB and BA are the same, but generally speaking, they are not, which we'll hopefully see here. So we write them next to each other. BA is going to be B times A, B first, A second. B times A, B times A, B -4, 1, 3, -6, times A, times 1, 3, -5, 2. My rule, circle the rows of the first matrix, circle the columns of the second matrix. 2 rows here, 2 columns here, so my answer will be 2 rows, 2 columns. So BA will equal row, row, 2 rows, 2 columns. So you move your fingers across. -4 times 1 is -4. 1 times -5 is -5, so -4 plus -5, or -4 minus 5 here. First row, second column, -4 times 3 is -12. 1 times 2 is 2, so -12 plus 2. Second row, first column, 3 times 1 is 3. Negative 6 times negative 5 is 30, so 3 plus 30. And then second row, second column, 3 times 3 is 9. Negative 6 times 2 is negative 12. So if we do this, simplifying the arithmetic, we get BA is negative 4 minus 5 is negative 9. Negative 12 plus 2, negative 12 plus 2 is negative 10. There really is no comma there. I probably shouldn't have put that there. 3 plus 30 is 33. 9 minus 12 is negative 3. Notice that does not look like what we had for AB. So negative 9, negative 10, 33, negative 3. Let's see if the calculator agrees. BA, second matrix B, times second matrix A. What do we get? Negative 9, negative 10, 33, negative 3. Good. So that's correct. That agrees with what we expected it to be. And what else do we have to do? We want to find A inverse and B inverse. So let's go ahead and do that next. A inverse and B inverse. Very easy. The calculator does that for us, but let's show at least one strategy that I like for these 2 by 2 matrices. Okay. So we have matrix A here, and what's its determinant? What is the determinant of A? Start upper left 1 times 2 minus negative 5 times 3. So the determinant of A is 2 minus negative 15. So that, of course, is 2 plus 15. Determinant of A is 17. Now, how do I use that to find A inverse? Well, let me show you. A inverse, the denominators are 17. Again, 2 by 2 slots. 17 here, 17 here. Main diagonal, upper left and lower right. It was 1, 2, switch those 2 guys. So the way I find an inverse is I switch the main diagonals. Upper left, lower right gets switched. So 2 moves up here, 1 goes down there. And then the off diagonals, 3 and negative 5, get their signs changed. So positive 3 becomes negative 3, negative 5 becomes positive 5. So that should be A inverse. 2 17ths, negative 3 17ths, 5 17ths, and 1 17th. Denominator is the determinant. So let's look at the graphing calculator and see if that is correct. So again, I've got my matrix A here. We'll just make sure it's inputted correctly. Matrix A, 1, 3, negative 5, 2. Then we'll take matrix A inverse. The inverse button is here, and it gives me a whole bunch of decimals. Let's change those to fractions to see if it agrees with what I said. Math changed to a fraction. What do we get? 2 17ths, negative 3 17ths, 5 17ths, 1 17th. Very good. That's exactly what we said for our A inverse. Now let's repeat this process one more time for B. So I need to get the determinant of B. So we see B over here. You start upper left. What is the determinant of B? Negative 4 times negative 6. Minus 3 times 1. Upper left times lower right minus the other 2 guys multiplied. So the determinant of B is 24 minus 3, which is 21. Okay. So to get B inverse, we have 21 downstairs for all 4 slots. 21 is downstairs for all 4 slots. 21, 21, 21. 21. Switch the people on the main diagonal. Negative 4 and negative 6 have to switch. So negative 6 moves up here, negative 4 moves down there. And then sign changes, the other 2 get sign changes. 1 becomes negative 1, 3 becomes negative 3. This we probably should reduce. So let's see how we do that. If I divide by 3, negative 6 divided by 3, negative 2, 21 divided by 3, 7, negative 121 does not reduce. Negative 3 over 21 divided by 3, negative 1. 21 divided by 3, 7. Negative 4 21s does not reduce. So I believe that is B inverse. We will check on the calculator to see if that's right. We go back and we go to matrix, B, make sure it's inputted correctly, negative 4, 1, 3, negative 6. That looks good. We want B inverse. Second, matrix B inverse. The inverse button is here, and it gives me a whole bunch of fractions again. Excuse me, a whole bunch of decimals. Let's change it to fractions. Does it match up? Negative 2 sevenths, negative 1 21st, negative 1 7th, negative 4 21st, which is exactly what we said we would get for B inverse.